Okay, so we're going to go ahead and start. We wanted to go ahead and do this webinar so that we could introduce all of the field people to this new product that we've been working on for about a year and a half now. We have the first one installed as a beta site for over a year now. They actually purchased it. They were that happy with it um, at a local wastewater treatment plant. So we're going to go through a PowerPoint presentation. You should be able to see that and also see a image of the inside of the digester monitor. We're going to use that to point out some features and benefits as we're going through the PowerPoint presentation. You can see from the picture and also on the screen that it's built into a NEMA 4X box, so it's very corrosion and water resistant. A lot of these applications will be nasty environments. The main design work on this product was the sample system. The problem there is that many of these gas streams that you're going to be analyzing have very high humidity and high temperature. So a big part of the challenge in the design was to be able to handle those conditions. And I'll go into that in more detail later. We needed to accurately measure very high levels of H2S, much higher than we're used to in safety applications, up to thousands of parts per million. And we designed it so that you could have up to 4 sensors installed, including a methane sensor for up to 100% volume, a CO2 sensor up to 50% volume, an oxygen sensor, and then an H2S sensor with 3 ranges available, 1,000, 3,000, or 5,000 ppm. And what we found is that typically the gas coming off of these digesters is around 60 to 70% methane, mostly CO2 as the balance, and then a small amount of H2S. It's large to us, but small in the total percentage of the sample. We use an aspirator to draw the sample. It can actually draw very long distances, but because of the high humidity in the sample, you generally are going to want to have the monitor as close to the sample point as possible to avoid getting a lot of condensation in the sample line. We have a self-draining moisture trap as part of the water protection system. There's an automatic back flush of the sample system so that if you do get any contamination in there, it'll get blown back out at the end of the cycle. I mentioned we use an aspirator rather than a pump to draw the sample. An aspirator is just a mechanical device that you pass compressed air through to create a vacuum. And it's much more durable and long-lasting than a pump would be, especially with the harsh environment we have to deal with. I mentioned before it has a NEMA 4X enclosure, so it's very weather resistant. Some of the applications that we're looking at, the primary one is for digesters in wastewater treatment plants. And the bottom left image is an actual digester. That dome is actually a dome within a dome. Inside that outer dome, there's actually a membrane that can expand and contract as it fills up with gas. We'll talk a little bit more about that process later. So wastewater treatment plants is a primary application. Landfills, you can see the chats, right? Yeah. If they ask any questions, okay. Landfills, dairy farms, large-scale dairy farms, and also other animal farms. And animal farm lagoons, which is a nice sounding thing, but it really isn't. It's basically a lake of animal waste that they cover with a membrane and then recover the methane from inside that membrane. So the reasons for monitoring, of course, this is all related to recovering the gas and using it to create energy. So the customer wants to use this gas to run an engine to generate electricity. And this gas is, as we mentioned before, is typically very high humidity and high H2S content, which makes it very corrosive. The H2S will damage the engine, so you have to control and remove the H2S. Typically, they'll do this with some type of a chemical scrubber. And the customer may want to check H2S both at the intake to the scrubber and the exhaust from the scrubber. At the intake so that they know what's going in, because the scrubber doesn't have a certain capacity. And if it gets too high, they may not be able to scrub adequately. And I'll talk a little bit more about that based on our experience at our beta site. They may want to measure the methane level. We originally thought that was the primary reason, but we've found that H2S seems to be the thing that they're most concerned with and most wanting to be able to monitor. But they can measure the methane level also, so they know that the quality of the gas and whether it's adequate for running their engine. They may also want to detect oxygen to prevent an explosion. If oxygen gets into the digester gas, of course, you've got a flammable gas normally with no oxygen. If you get enough oxygen in there, you can have an explosion. The process will also, if oxygen starts showing up, it could be a sign that their digester is not working properly, and that can be a problem for them. And then if there's air getting in, that can also be a problem. It could be a breach of the system. And again, it could lead to a flammable situation. You can also measure the CO2 level. Again, we have that capability, so we put it in. I'm not sure how interested all the customers are going to be in that, but we have that capability, and that's the other primary gas that's going to be in the digester gas. Some of the features and benefits. This is the primary one. We know that there are a lot of people that have tried to use more conventional equipment for this application, including us, and it just won't hold up because of the environmental conditions of the gas. So we have a 3-stage moisture humidity control, and I'm going to point that out with a pointer. So if you look at the image of the digester, stage is a water trap, which will take out any condensate that comes in. And as the system's running, that trap is constantly being drained by vacuum from the aspirator. So any water that comes in will immediately be flushed out through a drain. The second stage is a drying tube, which I'm pointing at here. It looks like just a piece of tubing, but it's actually a Nafion dryer, which is an ion exchange membrane that will allow water to move back and forth across the membrane. So the sample is very humid. It's flowing in one direction into the instrument, and then we blow compressed air the opposite direction through the outer surface of the dryer, so it tends to strip moisture out of the sample. That's what this tube here is. And then the third protection is a hydrophobic filter, which will, if somehow any condensate makes it past the other traps, the hydrophobic filter will stop it from getting into the sensors and the rest of the system. And I mentioned we have a beta site. They've had their system running for almost a year now, and they've had absolutely no trouble with any kind of moisture problems. So we think the design is doing what it's supposed to do. As I mentioned before, we have high range of H2S detection up to 5,000 ppm. We use infrared sensors for methane and CO2, so they're not damaged by this bad environment that the sample is producing. One of the really good features about this is an automatic zero adjustment. Every time a sample is taken, the first step is to flush the system with fresh air and zero it, so you have very good zero stability. I mentioned before the aspirator provides the sample, so there's no pump, no moving parts. Again, very durable and should be a long life system. We do have an option for a horn strobe on it. On the data sheet that we'll pass out later, it shows it with the horn strobe, which can be mounted on the top. I don't know how many people are going to need it because this is really not a safety device. It's not generally an alarm situation. They just want to get the data so they know what to do about their process if it gets out of whack. You have a user adjustable cycle interval from 15 minutes to 24 hours. And I'll talk a little bit about that. Because of the nasty environment, the H2S and the oxygen sensors will not hold up if they're exposed to the gas continuously. So the whole design is based on a cycle where cycle starts, it brings in fresh air, makes a zero adjustment. Then it takes a sample, and at the end of that sample time, it holds the reading until the next sample comes. Then it does a purge to flush out any gas that's in the system, and then it does a back flush to blow back air through the sample system to blow out anything that might have accumulated during the sample time. And again, the beta site that we've had absolutely no problems with that. We've never seen any accumulation of anything in the system. The digester process tends to not be very dynamic, so every user that we've talked to has not had a problem at all with the fact that it's not a true continuous monitor. I mentioned before we have IR sensors, so there's no problem with getting contaminated or poisoned. And we're using our partial pressure oxygen sensor, which is a very long life sensor. Here's a price list. We'll be passing this out after the meeting. You can buy it with 1, 2, 3, or 4 sensors. And like I said, we'll send this out to you. The prices might seem high, but let me give you an example of why this is very, very valuable to any wastewater treatment plant that's running a digester. The guys that have the beta site, right before we delivered the system to them, they had been taking samples periodically with Draeger tubes to check the H2S going into their scrubber. And they didn't do it often enough. And their system got out of whack, and they were generating, normally they generate anywhere from 50 to a few hundred ppm of H2S. That's kind of normal if everything's working right. Their process went out of whack, and they got up to, they think, about 4,000 ppm without knowing it. And it ran that way long enough to ruin the material in their scrubber. And then when that happened, then the H2S gas goes through to their engine, and they ruined their engine. So between those two things, it cost them about $75,000 just for that one incident between rebuilding the engine and replacing the material in their scrubber. So one accident like that will more than pay for the system. And they bought their beta unit recently because they've been so happy with it.
Is that the one up in Marin?
That's the one up in Marin, yeah. Lenny, do you want to say anything about that? Lenny is here with us live, and it's one of Lenny's customers who also has a lot of our portable equipment up there.
Well, the only thing I want to comment, it originated, we had sold them some portables for the confined space program for JICS 2012s. And then once they learned that we had fixed systems available, they started to inquire about just a Beacon 410, just a general 4-gas monitor. And then they asked us, the immediate needs were for this digester fixed system. And I looked at the guy with a funny look. I had no idea what he was talking about. So I called Bruce and got him involved. And he said, "It's funny that you mentioned that. We're in the process of building something very similar to that might work for their setup." So that's how the beta test started. But after getting going out there, I think Ken's been out there multiple times. I've been out there 3 or 4 times, mainly on the portable side of it, but asking some questions on the digester, how the unit's going during the beta testing. And they had mentioned that it's a project that's very near and dear to them. It's called a FOG project in industry terms. It looks like most of the wastewater treatment plants are doing it. And the FOG stands for fat, oils, and grease. And basically what they're doing is taking recyclables from like restaurants and trucking it into the digester and then processing it. And then the outcome is methane gas, which they're reselling to PG&E or other local utilities. So, but talking around to the other wastewater treatment plants, it seems like they're all either putting these things online or budgeting to build these FOG units to tie into the digesters like Bruce says. So it looks like we're at a pretty good stage of launching this product. The competitive product that they told me that they were going to evaluate before ours was called from Siemens, and I think it was $75,000 for their, and they couldn't do CO2. I believe it was just H2S and LEL, possibly O2, just 3 gases. So that's all I know.
There's a couple questions on the board, but I wanted to talk a little bit more about the economics of it. In California, the wastewater treatment plants now are being mandated to recover this gas and use it to generate electricity during the peak hours. And if they don't, they pay a premium for their electricity, and they also get fined. So it's very important for them to run these digesters and generate electricity. And at Marin, where the beta unit is, when their system's running, they actually can generate excess electricity and sell it back to the power grid. They run the digester, the engine, I'm sorry, during the day when they're consuming the most of their power, and then at night they shut it down and let the gas reaccumulate in the digester storage. If you look at that image on the bottom left, they have one digester that looks exactly like that. They have a second one that was an older one that had a floating roof. And you could actually see during the day, in the beginning of the day, the roof would be full, and they would start using the gas to run their engine. And by the end of the day, it would be pretty much empty, and then they would shut the engine down and allow the gas to reaccumulate.
So that's not a hard top then?
That one is a hard top, but inside that there's a balloon that
right.
basically inflates.
So if they don't really want it to get it can't expand any more than that.
Right. So what they do is if their digester engine is not running, then they have to flare the gas off, and they get penalized for that, and they also get penalized for their electricity consumption. So a couple of questions. John asked, are they using the 4 to 20 milliamp signal for the management? They could. In this case, they're actually using the Modbus signal, and they're running it to their SCADA system. John also asked, is it just to prevent damage to the compressor or engine? That's the main reason for monitoring the H2S level, is to prevent damage to the compressor. I'm not sure what you mean by compressor, John, but the engine takes the natural gas and burns it to create electricity. So they're worried about damage to that, and they're also worried about overwhelming their scrubber system. So that's the main reason why they're looking at H2S. And then Don Tual says, Don, what's your comment about UC Davis?
I was just reading about the READ program at UC Davis and their capture of methane for renewable energy.
Okay. Yeah, one of the shows that I've targeted is a renewable energy conference, a national one that's in San Diego next year. That we're planning on taking the digester there.
Well, and you and I still need to talk about that LMOP show in Baltimore,
right,
coming up in January, the Landfill Methane Outreach Program.
Yep,
that's put on by EPA.
And John also mentioned there's a WEFTEC show that he thinks might be a good place for this to be exhibited. Todd's asking a good question. How does it reset the levels like the peak? Basically, what happens is at the beginning of the cycle, as I mentioned, it flushes out the system and does a zero, and then it takes a sample and it takes the peak reading during the sample period and locks that in. At the end of the sample, it flushes everything out again, but the peak reading is locked in until the next sample is taken. So every time it finishes taking a sample, it resets all the readings, and that's what's displayed on the display. And the 4 to 20 milliamp output and the RS485 outputs all reflect those latched-in readings. Any other questions from anybody?
When do we expect to be in production to start to actually be able to sell them?
That's a good question. We have finished the design, and we are procuring all the parts. There's a couple of little items that we have left that are due, I think, now, or maybe they're already here. So we're ready to go into production now. We've got all the documentation done. We're going to be doing a release for this. What's the schedule for that? Do we have that scheduled yet? Soon. I'll say soon. We wanted to present it to all of you guys first, so that you had firsthand information and knowledge before we announce it to the rest of the world. But we're ready to go into production, and we have a couple samples built. Go ahead, Gary.
Well, just one of the things that I found out about this in calling upon those people is that these green farms that are doing this return of methane into power, et cetera, and doing all those, they're getting federal credits, tax credits back for doing that. So there is an enhancement for them to go ahead and do this kind of thing on their farm, whether it be a dairy farm or whatever it may be. In this case, it happens to be a 9,300-acre farm. So anyway, they get tax credits for doing this. Okay.
That's a big incentive, yeah.
So in addition to getting to cut their electricity bill, they can get a tax credit as well. So it's a double benefit.
Yes.
And they can feel good about the fact that they're being green, which is also a good benefit.
Mm-hmm.
Bruce, is this?
Hey, Bruce, it's Jack. I've had this link on my computer for a while. I just sent you guys a map of all the biogas locations, farm, wastewater plant in the country.
Good. That must be a busy map, I would think.
Well, it's the National Biogas Association. I found these guys like probably 3-4 years ago when we started using the TC sensor and doing this like before this digester thing.
Yeah, we have some people
I
that have
followed
been
your
using
email up with one of my own that's from the EPA landfill gas energy projects, and those are not only existing ongoing projects, but there's candidate landfills as well. Those are considering for future. So that's worth looking at as well.
Yeah, we think this is going to be a really growing market. There's a huge impetus right now from the government on state level and federal levels for renewable energy. And all of these types of systems are going to be going into place. Sandra asked a question, do we need any approvals? We don't think so, because these are generally installed outside near the digester, and they're not classified areas. So there shouldn't be any approval required. If you look at that image on the bottom left again, that's very similar to what the Marin one looks like, only they have one like that and a second one. And the digester is in between, the digester monitor is mounted on a rail in between the two digesters. And then it goes to both of them feed a scrubber, and we're monitoring, in their case, the gas on the intake side of the scrubber. And they put a valve in place too, so that they can switch the flow and check the output of the scrubber when they want to. But primarily, they're just looking at what's going into the scrubber, because they want to know that the process has to be maintained at a very stable condition. It has to be a high temperature. That's another thing they use the gas for, is they run a burner that heats up the gas inside the digester, because the biological activity has to be maintained at a constant temperature to get the methane generation right. And it's typically about 120 degrees F.
Did you say they monitor the gas as it goes into the scrubber?
That's correct.
They don't check it when it comes out, where it goes to the engine?
They check it once in a while, but they're more concerned with what's going in, because they know if their process is working right. They have a certain level of H2S. If something goes out of whack, like for some reason the temperature inside the digester isn't stable, or they get a slug of something in there that upsets the process, it changes the amount of H2S. And if that level goes very high, like I said, it can overwhelm the scrubber and also eventually damage the engine. So they're more concerned with what's going in than they are with what's coming out.
Okay.
And they have a super efficient scrubber. They can put in, I think they set up to 1,000 ppm H2S, and they get basically zero out. But they have a very new technology scrubber. They couldn't really tell us anything about it, because the manufacturer is very secretive about how the scrubbing system works. But they showed us their old scrubber, and it was basically a kind of like a wooden box with redwood bark in it, and they were passing the gas through there and the redwood would absorb the H2S, but it was really inefficient. And they got a lot of H2S out of it, but it was all they had in the beginning.
So Bruce, on each one of these types of applications, is the process and the outcome of what they're trying to find out the same?
Yeah, they're all doing, it's different ways of doing the same thing, which is generate methane from biological activity. And because of the nature of the process, there's always going to be hydrogen sulfide there that they need to deal with because it'll kill the engine. In the wastewater plants, they also have to deal with a material called siloxane, which will also damage the engine and is part of what's generated from the digester. And they have a big siloxane scrubber there as well.
The landfills will have that as well.
And landfill gas also. It's all the same thing in terms of you're basically decomposing biologically organic material. So you're going to get similar outcome from any of these processes.
One thing that we're seeing is that people may ask us just for H2S monitoring, but then as they learn what else it can do, they end up wanting most or all of the other gases as well.
You mean oxygen and CO2?
And methane.
And methane.
And if you look at the pricing, I mean,
that
was one thing I was going to mention. I'll point out a couple things. The system's based on the Beacon 410 controller, but it's a highly modified firmware that uses the Beacon 410 smarts and relays to control all these solenoid valves. These red things in here are solenoid valves that open and close during the sequence to direct the airflow and the gas flow in the right way. So we use the Beacon relays and firmware to control the sequencing of those solenoid valves.
Has there been any study about other states besides California as to their regulations and tax credits and things of that nature?
Not yet. John, I'm sorry, there's a couple more questions on the board. John's asking, we need to define business between landfill and digester. I'm not sure what you mean by that. Are you there, John? Okay. And then John Foster's asking, the operating temperature on the unit states 0 to 40 Celsius. That's the ambient temperature. And I'm not sure how it came up with that.
I'm not sure either, and I'm thinking it probably can be way wider than that, because the Beacon 410 itself will go down to
it's minus 20 to plus 50. Is the standard spec. So we'll check that out, John. I think that's not right. I think it'll go much colder than that. And we have a new optional display for the Beacon 410 now that is a wider temperature range. It'll go down to minus 40.
Bruce, where are these things mostly hooked up, or are they indoors, outdoors?
It could be indoors or it could be outdoors. It depends on how the plumbing system is set up and what kind of environment's there. The one at Marin is outdoors. It's just mounted to a rail on a walkway that's next to the digester.
Which is next to that big thing there,
right? Right.
Typically, the scrubbing system is always outdoors next to the digester. So,
okay,
yeah,
so that's where it would go. So if you've got severe weather, pummeled it with rain, that's not going to affect anything, or?
No, because it's a NEMA 4X box.
I can see how very cold weather might be an issue, though, not to our box, but to the sample line. If you have much of a sample line between the digester and the monitor, they're going to get condensation because the air is warm and humid coming out of the digester. So it'll condense and maybe even freeze in the sample line if it's below freezing.
That's right. I was going to mention that. That's one reason why they're going to want to keep the digester monitor as close as possible to where they're actually sampling, so that they don't have that opportunity for the line to freeze up.
Hey, Bruce, I'm sorry. May I ask my question again?
Yeah, go ahead.
And the limited exposure that I've had to the people in Wisconsin, I've found that there are digester engineering companies, people that are dedicated to the digester business, and they don't necessarily cross over into the landfill business.
Mm-hmm.
And we also place calls to environmental engineering companies that do mostly landfill but don't do any digester. Is there an opportunity to discern between different packages? For instance, it's my understanding that landfills primarily want to see percent by volume gas concentrations. And as you stated, the digesters generally are more interested in H2S. Would it be worth our while to understand both those as two completely different applications?
Well, if they're not worried about H2S, they may not need the full digester package. They could use an M2, for instance, with a 0 to 100% methane sensor and an aspirator and do the same thing. The reason for the digester monitor is if they want to monitor H2S or oxygen, you have to use this technique for the sensors to work and stay working and stable.
Well, for that reason, I'm always curious because the comments that I received from the environmental people is they wanted to dumb down our box. They wanted to take some of what you had in it out, and they would come back to our very basic aspirator with an M2 head and a bypass. Would that be something that we should be aware of when we bring the digester into a landfill or an engineering company for landfills?
Yeah, we can always offer them options depending on where they're making the measurement and what they want to accomplish.
Is there a way that we can get a schematic of where these units are placed within the process? Or even a rough draft of where it's placed within the process that you guys have in California?
The one in California is pretty straightforward. There's a pipe that runs from the digester to the scrubber, and they're sampling off of that pipe right as it goes into the scrubber.
I got a photo I can email the group.
Yeah, we can. We've got some pictures that we took that we're going to put together when we do our application brief for this.
Excellent.